Welcome to this explainer. Today, we're diving into a sleek, state-of-the-art methodology designed to literally save your AI workflows from themselves. We're talking about the anti-collapse architecture of the ACE framework. Think of it as an IDE-agnostic standard that treats your AI interactions as rigorous, structured transactions rather than just, casual, chaotic conversations.
Okay, let's kick things off with a pretty provocative question. What happens when your AI just forgets? We're plunging right into the fatal flaw of standard AI coding workflows here. Because when we use AI ad hoc, without any kind of standardized framework, we're basically relying on a system that constantly overwrites its own memory. Let's look at exactly why that happens.
Section 1. Context collapse and brevity bias. Now, picture a glowing AI brain attempting to rewrite a massive code-based document. As it works, trying to be super efficient, critical historical edge cases visually evaporate right into the dark background. They're just permanently lost. This is what we call brevity bias. The AI genuinely thinks it's optimizing, but actually, it's destroying your institutional knowledge. And as those data nodes evaporate, your project suffers from full-blown context collapse. Research actually shows that models can lose track of your initial instructions in just a few iterations. The symptoms are pretty severe. You get a loss of focus and state across different sessions, degraded architectural standards, and eventually, the AI just starts rampant hallucination. It literally loses the guardrails protecting your enterprise system.
Which brings us to Section 2, the deterministic append shield.
Let's contrast those destructive rewrites of standard AI with the framework's actual solution. Visualize a sleek, glass-morphic mathematical shield slamming down. This physically blocks the AI from ever modifying your master standard files. Instead of rewriting, the framework forces deterministic appends, meaning updates are applied in a strictly controlled way without ever touching that historical data. So, the absolutely crucial point here is that you never use a single, continuously running LLM conversation for a whole project lifecycle. Those long-running sessions are exactly what cause the model to forget instructions and hallucinate in the first place. Instead, the framework uses context flushing. When shifting phases or changing roles, the system flushes the context and starts a fresh, clean slate session. It loads only the exact files needed for a single isolated action. It stops that degradation right in its tracks.
Moving on to Section 3, the AI Agent Triad.
This three-part modular cycle formalizes exactly how lessons are learned, analyzed, and safely stored. First up, the generator. It acts as the developer, executing tasks using explicit reason and act, or react, traces. Basically, it has to document its logical thought process before taking action. Then the reflector acts as QA. If a failure happens, it analyzes the generator's dense feedback and distills it into clear, natural language lessons. Finally, the curator takes those insights and integrates them to manage redundancy.
Section 4, the curator funnel metaphor. So visualize the curator dropping a glowing data crystal, which represents a brand new distilled lesson, into a sleek, high-tech, one-way funnel. It smoothly descends. The flow of information only goes in one direction here. It can't go back up, and there's absolutely no way it can alter the crystals already in the funnel. And that is all thanks to the strict rules of the funnel. The curator is absolutely forbidden from rewriting standard files. Instead, because of that mathematical shield we just talked about, updates apply via deterministic append scripts. The new data crystal perfectly and safely concatenates. It just locks right into place at the very bottom of a transparent, indestructible stack of knowledge.
Which leads us to our final section, Section 5, the endless knowledge stack.
You end up with this endless stack of knowledge. Every single time the triad runs and a lesson is learned, a new crystal is appended. And this transparent stack scales upward infinitely into the dark void. Because the system is append-only, every edge case, every bug fix, and every architectural decision is permanently secured. Not a single node is ever lost to brevity bias again.
The memory only grows. It never shrinks. This kinetic typography really locks in the core thesis of the framework. By treating AI interactions as structured, file-based transactions instead of casual chats, you create a permanent cumulative learning environment. Your AI actually gets smarter and perfectly aligned with your project standards every single time it runs.
I'll leave you with this final thought to consider. The era of unpredictable, chaotic AI code generation is over. So, are you ready to stop fighting your AI's tendency to forget
and start building an endless, indestructible memory for your codebase? Think about how implementing a deterministic anti-collapse architecture like this could completely transform your own AI workflows. Thanks so much for joining me for this explainer, and I'll catch you in the next one.